Hi there. Here's example 1 from the Managing Inference Errors review. So we are interested in finding a sample size. So understand, we haven't actually done the sampling yet. So we need to find the size used to make a 95% confidence interval for a mean. And I want a margin of error of 20 points. So something to think about then from the formula sheet, here is how you actually build a confidence interval. So after the statistic, we add and subtract the margin of error. It consists of a critical value times the standard deviation of the statistic. And here is the statistic we're going to use. That's the sample mean. Now, understand, we are trying to find the sample size. We haven't taken the sample yet. So I don't have a sample standard deviation that I can put in the place of sigma. That's why I'm going to make an estimate of what I believe the population standard deviation is. But by using what I believe the population standard deviation might be, that means instead of using t-scores, I can go ahead and use a z-score here in order to try to make this estimate to help me make the sample size. So the margin of error that I'm interested in is 20 points. That margin of error is made of two pieces. In this case, it is a z-score. And then I am going to multiply by the population standard deviation divided by the square root of the sample size, and that's my goal. I'd like to find that sample size. Now, understand, I'm assuming that the population standard deviation is 110, no problem. I don't know the square root of the sample size. That's what I'm trying to find. But this z-score, this is something that you should recognize. For 95% confidence, the z-score that we use is 1.96. It is not particularly hard to remember how to do that on your graphing calculator. It's something that you would want to know how to do. So for a 95% confidence interval, we're cutting off 5% of the distribution, the upper and lower 2.5%. So if you go to second variables, under the inverse norm command, if you put in that 2.5% that we're cutting off of the bottom, you get the lower z-score, the lower critical value of negative 1.96. Of course, you could also go to inverse norm, and instead of putting in the 0.025, you can add the 0.025 to 95%. You could put in 0.975, and that'll give you the positive value. Either way, for 95% confidence, it's 1.96, and if you don't need to use your calculator to do that, more power to you. So this is what you want to solve in order to find your sample size. So I would write it as 20 over 1, and that equals, let's see, 1.96 times 110. That's 215.6 over the square root of n. So cross multiplying here, 20 times the square root of n, that's going to give me 215.6 divided by 20. And then ultimately I'm going to take the square of this value. So I'm going to take 215.6 divided by 20. Something important to think about then, something you always want to do. I'm going to take 215.6 divided by 20, and I want to take the square of that result. So notice you get 116.2. So we don't want to round this down to a sample size of 116, however, because to get 95% confidence, I need the 0.2084 of an observation. So you always round up in this context. That would turn this into 117.